So section 7 of the free response are just random ones. Sometimes you get them, sometimes you don't. So I thought I'd do a few for you. So 2014, this was a non-calculator. It gave you a chart, and it told you it was twice differentiable functions, f and g, defined for all real numbers. And part A says find the x-coordinate of each relative minimum of f on the interval of -2 to 3. Justify your answer. So remember, to be a minimum, the derivative would have to change from negative to positive, and it would also have to equal 0. So it's not going to be at -2 because f prime is not 0. So it could possibly be at -1 and 1. At -1, it doesn't change. It just stays negative, so it wouldn't be a minimum. But at x equal 1, it changes from negative to positive. So that's the justification, and that would be the minimum. Part B says explain why there must be a value between -1 and 1 such that f double prime of c equals 0. Well, this is the mean value theorem. So if you do f prime of 1 minus f prime of -1, you do get 0. And since it's differentiable and continuous, the mean value theorem says there must be at least one value c that equals f prime c equals 0. So remember, mean value theorem, you do f of b minus f of a, and whatever that's equal to, there will be a c that's equal to that. Part C, the function h is defined by h of x equal ln of f of x. Find h of 3. Show the computations. So this is your function. If I take the derivative, remember the derivative of ln is 1 over f of x times the derivative of the inside. So then I can just put 1 over f of 3 times f prime 3, go up to my table and get my values. Be 114. And D says evaluate -2 to 3 f prime g of x, g prime x. So that's what you've got. So you let u be g of x, then du would be g prime d of x. So that takes care of that part. So then you got f prime of u. So that means, remember, when you take the integral of the derivative, it's just f, and my u was g of x. So it's f of g of x, 3 -2. So I'm just going to do f of g of 3 minus f of g of -2. G of 3 is 1. G of -2 is -1. F of 1 is 2. F of -1 is 8. So your value is -6. The 2012 gives you a function. First it says find f prime of x. So we're just going to do our chain rule. Clean it up. That's easy enough. Part B says write an equation for the line tangent to at x equal -3. So we're going to come over here first, get our ordered pair. So we're going to plug that in. So our ordered pair is -3, 4. And then we're going to get our derivative. So we're going to plug that into what we just found. And we're going to get 3/4. Plug it in y mx plus b, solve for b. And you get 3/4 x plus 25/4. So part C says let g be the function defined by this. Is g continuous at x equal 3? Use the definition of continuity. Now remember, there's 3 steps to prove continuity. You've got to prove that the limit exists. So you see if the limit approaching from the right. So from the right, it's going to be here. So -3 plus 7 would be 4. Limit from the left. I'm going to come up here. 25 minus -3 squared will be 16. Square root of 16 is 4. So since both of those are the same, the limit does exist. Does the point exist? At less than or equal to -3, it's here. Does that point exist? Yes. That is 4. And so and then the third condition is, does the point equal the limit? And it does. So those are the 3 conditions. And part D says to find the value of 0 to 5 of x 25 x squared. So we're just going to come down here. We're going to do u is this, du is negative 2x. So if I add a negative 2 in, I got to negate it by negative 1/2. I'll just do my power rule. I'll get negative 1/3 raised to the 3/2. I'll plug 5 in, and that'll be 0. If I plug 0, you're doing 25. So since you're doing the 3/2 and it's non-calculated, I go 25 to the 1/2, which would be 5. And then 5 cubed would be your 125, which would be negative 125. So negative, negative makes your positive 125 thirds. So 2010, we've got a 2 and a 3. That's calculator active. So if you look, they give you g of 1 equal 2, g prime, g double prime, and this is calculator active. So it says find all the values between 0.12 and 1 where it has a horizontal tangent line. So that's going to happen where your first derivative is equal to 0. So you can just put this in and put 0 and find your intersection. I would do your windows 0.12 to 1 since that's the interval you're going to. It'll be easier to find. And it's at 0.359 and at 0.164. And then it says on what subintervals from 0.12 to 1 is the concave down. So I would just look at the graph, put your windows there, and use your trace button because you want to see where the first derivative is decreasing, and it's from 0.12 to 0.22. The other way you could do it is you could put the second derivative in your calculator, graph that in that interval, and see where that's negative. Either way, it'll show you concave down. And it says write an equation for the line tangent to the graph at g equal 0.03. So I got to get g prime 0.3, so I'll just plug that in, and you get negative 0.4722. Now how do I get g of 0.3? I'm going to do g of 1 plus 1 to 0.3. Well, those intervals are in the wrong order, so I'll have to change it to subtraction. We know this is 2, and I can use Math 9 for this, and you get 1.54 as your ordered pair. So then you put that in for your y, your slope, your 0.3, and get your b, and that ends up being your equation. And part D says, does the line tangent the graph at 0.3 lie above the graph of G or below? So what you want to know is at 0.3 is the second derivative negative or positive, so you know concavity. So if you look that up in the table or graph, whichever way you want to do it, it's greater than 0, so the original graph is concave up. And if the original graph is concave up, then your tangent line is going to be below it. So let's look at the next one. They give you a table, they give you a drawing, they talk about being the swimming pool. It's got a radius of 12 feet, height of 4, pool contains 1,000 cubic feet at the beginning. P of T, which is your table of values, is the rate in which the water is pumped in the pool. And R of T, which they give you a function rule, is the volume where it goes out. And then they give you the volume formula. So it says use a midpoint Riemann sum with 3 subintervals of equal length to approximate the total amount of water that's pumped into the pool, 0, 12. So if you got 3 are going to 12, 4, so you got this one, and this one. So you know your width is 4, and you're just going to take your midpoint values, add them up, and you get 660 cubic feet cubed. Now calculate the total amount of water that leaked out of the pool. So that'll be 0, 12. R of T, you can use Math 9, and that's 222.594. So C says use the results from part A and B to approximate the volume of the water at time equal 12 hours. So you want the total volume, so you're going to put what you started with it pumping in minus out 1,000. We already got this with 660. We got this minus 222. And if you put that together, you get 1434.406 feet cubed. Now it says find the rate at which the volume of water in the pool is increasing at 8 and how fast is the water level rising at t equal 8. So the first one, if you want to find the rate in which it's the volume of the water, you want how it's coming in minus how it's going out. So P of 8 minus R of 8, you just plug that in and you're going to get, because P of 8 comes straight from the table, and you can plug R of 8 in and you get 43.241 feet cubed. Now when it says how fast is the water level in the pool, we want dH dt. So we're going to go back to our original volume formula. Volume equal pi 12 squared h. So volume equal 144, that should be pi h. So when you take the derivative, dv dt equal 144 pi dH dt. I'm solving for dH dt, so I'm going to do 144 pi dv dt. And I just found dv dt, so I'm just going to do 1 over 144 pi times 43.241, and I get 0.095 feet per hour.